Hi everyone, today we will see about genotype plus genotype environment interaction using RStudio and more specifically using the package what we call the method. So let me define briefly about genotype plus genotype environment interaction means. It is nowadays widely used for the genotype evaluation and the mega environmental trail or in identification in multi-environmental trails. So these models considers a GGE Biplot, that means genotype plus genotype environment interaction, which is constructed by the first two symmetrical scaled principal component, that means the PC1 and the PC2. It's derived from the singular value decomposition environment centered multiple environment trail data. So the GGE Biplot graphically displays the genotype plus the genotype interaction of the multiple environmental trail in a way that facilitates the visual genotype evaluation and the mega environment identification. So it also uses the function the GGE. This helps us to run the genotype by genotype plus genotype environmental interaction. So to produce the model, you have to this function supports four methods. One is 4 methods of data centering, and 2 methods of data scaling, and lastly 3 optional for SVP or singular value partitioning. For example, as I mentioned before, it is used for method of centering. There is 0, 1, 2, and 3 centering methods. So 0 means it is non-centering, and while when you say it's 1, it's a global. For a global center, that means environment plus genotype environmental interaction. And if you say if you center is equals to 2, it is environment by default, but for environment center, that means genotype plus genotype environment interaction. So if you say center is equal to 3, it is for a double center, that means genotype environmental interaction. So Biplot cannot be produced without module that is without centering. So if you don't centering, Biplot will not be generated. So the second one is there is 2 methods of data scaling. There is 0 and 1. 0 means it is none, it's default for non-scaling, and 1 is sometimes we can also refer standard deviation, which each value is divided by the standard deviation of it is the corresponding environment or the column or tester. So this will put all testers roughly to the same range of values. And the third one is, as I told you before, there is 3 options for singular value partitioning or SVP. So 1 is genotype, that means singular value is entirely partitioned into the genotype's eigenvectors, also called it is a row metric preserving. The second one is the environment is default, so the singular value is entirely partitioned into the environment eigenvectors, and also called it is column metric preserving. The first one is the row metric preserving, and the third one is the symmetrical. That means the singular value is symmetrically partitioned into genotype and the environment eigenfactors, and the SVP is most often used in the additive and multiplicative interactive analysis and other Biplot analysis, but it is not ideal for visualizing either the relationship among the entries or among the testers. Entries are the factor to be used, and the testers are mostly, it is the environment, also it's as referred to as column. So the function GGE used to fit this model, and this function produce the genotype plus genotype environmental interaction model based on both of a two-way table with the genotype in the row and environment in a column, or maybe is a data frame that containing at least a column for genotype, environments, and the response variable, or if you have different or multiple variables, so it also included that. So to start our today's tutorial, you have to run library method, because our data is already built in this package. So in order to use a data frame, today we will use our data name is data. So to get the genotype plus genotype environment interaction is using the GGE function. So you can assign any name that you want here, and this is the genotype plus genotype environment interaction, our data name, environment, genotype, and the grain yield. So type this one and run. And also you can predict your model, so by saying predict and referring this name again, so you will get a result. It will combine different models. For example, let me maximize it. So the predict is the SS3 generic function that is used to predict the response variables in a two-way table based on the genotype plus genotype environmental interaction model. So this prediction is based on the number of principal components that you are used in. So this is about the model. Then let's back to the GGE plot. So the genotype plus genotype environmental interaction biplot use the function its plot. In order to create the biplot, you have to type this plot, and it is used to generate a biplot using as an input to fit the model of genotype or GGE. So if you type this one and run it, it will get the biplot. So and again, also it can give you several type of biplot. For example, type 1 is a basic plot that I'm running now, and the type 2 is the mean performance and the stability, and the type 3 is tells which one where, and the type 4 is discriminative versus representatives, and the type 5 is examine an environment, the type 6 is ranking environments, the type 7 is examine a genotype, and the type 8 is ranking the genotypes, and type 9 is comparing two genotypes, and lastly the type 10 is a biplot that indicates relationship among the environment. So this is type 1 is the basic plot that show you the basic one. So let me arrange the plot together. So as you see here in the graph, it will display the genotype as well as the environment all together. By the way, these biplots are similar, but their difference is their color, or it maybe depend on your preference. You can add either yellow, either red, either blue, whatever you want, you can adjust in this way. So coming to the second biplot type, this is a mean performance as well as the stability. So to do that, you can give any name that you want, and our function is GGE, and here is the environment genotype, and here is the SV value is the genotype. So it will show you the mean performance and the stability analysis. So type this one and run. So again, here is say you have to refer type 2, that means biplot 2, this is mean performance and stability. So type this one, and again, this also in similar fashion, you have to type this one and run together. So let me arrange the plot. So on the basis of this graph, as you see here that there is a line that comes here, and sometimes in different you can also use a circle. So on the basis of this, it clearly shows you that the visualization of the mean and stability of genotype is achieved by drawing an average environmental coordinate on the genotype focused biplot, and first an average environment represented by this arrow, and it is defined by the mean of principal component 1 and the principal component score of the environment, and the line that passes through the biplot origin and the average environment coordinates may be called as an average. So the projection of the genotype marker on this axis should be therefore approximate the mean yield of the genotype. So in this scenario, the G8 was clearly indicate that it is the highest yield genotype on average, and was followed by this genotype and this genotype and this genotype, and there is a greater projection onto the average environmental coordinates measures its variability or instability of the genotype. So even regardless to their direction. So if there is a greater projection, that it means it is a greater instability. So in our case, G3 is a very stable, and it is second productive to that of the G8, and as well as here G9 had a greater instability comparing to other genotypes. Then let's quickly jump to the subtype. That means which one where. That means which genotype is best and in which environment. So to do that, you have to use the GGE in our data environment, and SVV is symmetrical. So as I mentioned before, SV or the type 3 is which one where. So we will do this model by typing the following syntax. So it will clearly show you that which genotype is best in their environment. So to do that, GGE environment, genotype, grain yield, SV is equal to symmetrical. So this add the model, and the plot is the type 3. It is which one where. So type this one and run. By the way, these plots A and B are similar, but if you want to just further modification, you have to use this one. So, and again, type the second one, and let's arrange the biplots for the type 3 or which one where. Let's zoom in. Yes. And this plot, as you see here, there is a polygon is drawing by joining of the genotypes. For example, here is genotype 7, here is the genotype 8, here is the genotype 9, here is the genotype 10, and also this is not a point of joining, so don't include this genotype 5. Sometimes people are confused with such type of interpretation. So here is G4, G7, G8, G9, and the G10 are the furthest located from the biplot origin. So no one genotype is furthest from this genotype. For example, G9, if you compare G1, it's not furthest from the plot, from the origin. And if you compare the G6 with G4, it's not furthest like G4. So these are the furthest genotypes that are located from the biplot origin, so that all the other genotypes are contained in what in this polygon. So the vertex genotype have the longest vector in the respective direction, and which is a measure the responsiveness to the environment. So the vertex genotypes are therefore among the most responsive genotype, but the remaining all other genotypes are less responsive in their respective direction. So a genotype located at the origin would be ranked. For example, a genotype that are near to this origin would rank the same in all environment. That means, for example, G6 will have the same yield in 9, in 10, 13, 15, and 4. So those genotypes are found in the origin. That means they would have the same rank across all the environment, and it's not at all are responsive to the environment. And the other is the perpendicular line. To the side of the polygon, it divides. For example, it divides here, it divides here, it divides. Since we have 5 polygons, here is 1, 2, 3, 4, and 5 points. So there's also 5 perpendicular lines to the side of the polygons divide the biplots into the sector. So each sector has a vertex genotype, and for example, the sector with a vector vertex genotype 4 may be referred to as G4 sector, and while with the environment also what the environment 9, it is solely environment 9, so fell in G4 sector. Here you can draw the perpendicular line, and the G4 is fell in the environment 9, so this sector is, you can say, as G4 sector. So as a rule, the vertex genotype is the highest yielding. It is the highest yielding genotype in all environments that share the sector. For example, G4 sector is only there is E9 or environmental 9. So in case if there is E10 or E12, so this genotype will be based on the 3 methods, on the 3 environments. But as you see here, is the highest yielding genotype found is in the environment 9. So by this way you can discuss which one we're using the type 3 method. So I will come up with other types of biplots in coming tutorial, and if you have any question regarding my tutorial, you can provide through my email workstrategies@gmail.com, or you can provide on YouTube comment box. And thank you for watching. Have a nice time.